everybody. So my name is Anaïc Cordoba, legal advisor at the IPI, and I will talk about innovation, plant breeding, and patent transparency. Plant breeding has always been about innovation. From crossing and selecting to today's gene editing technologies, breeders continuously develop new plants and new traits to address challenges such as climate change and food security. On the next slide, you can see a gene-edited banana developed by Tropic. This banana was named Time magazine's Best Food Innovation of the Year 2025. What makes this banana special is very simple. After being cut, it does not turn brown. Behind this trait lies years of research, field trials, and investment. So how do we protect innovation like this? And what does that imply for breeders and plant breeding? The next slide shows the two intellectual property systems used to protect innovations in plant breeding. The first is plant variety protection. It protects the plant variety itself, for example, a new wheat or potato variety. It rewards the breeder for developing a new variety. The second system is patent protection. A patent protects a technical process for breeding or a specific trait obtained with such technical process. For example, this could be a genetic trait that gives plant better resistance to a disease. In Switzerland, under both systems, breeder can use existing plant for further breeding. This is essential because plant breeding builds on previous varieties. The main difference between the two systems appears when a new variety is commercialized. Under the plant variety protection system, the breeder can market the new variety freely as long as it is clearly distinct from the protected variety. Under patent law, if a new variety contains a patented trait, the breeder needs a license from the patent holder to market the new variety. So the key point is that these two systems are not competing. They protect different aspects of innovation, and together they support plant breeding innovation. Today, I will mainly focus on patents because they are currently at the center of policy discussions. Next slide, please. While these two systems work together in practice, patents in plant breeding have been the subject of significant debate. With the emergence of new genomic techniques, NGT, this debate has recently returned to the forefront. Three questions are often raised. First, can breeders use plants that contain a patented trait in their breeding programs? Second, can plants developed using NGT be patented? And third, how can breeders identify relevant patent in practice? To answer these questions, let's first take a closer look at what a patent actually is. That will be on the next slide. A patent is first and foremost a technical solution to a clearly defined technical problem. This means that abstract ideas, scientific discoveries, or natural laws cannot be patented. To obtain a patent, an invention must meet two key conditions. It must be new, meaning it has not been disclosed anywhere in the world, and it must involve an inventive step, meaning it must not be obvious to a skilled person in the field, so an engineer in the field. A patent grants an exclusive right. It allows the inventor to prevent others from using the invention. However, this right is limited. Patents last for a maximum of 20 years and are valid only in the country where they are granted. In return for the exclusive right, the invention must be fully disclosed, and patent applications are published in publicly accessible databases. Next slide, please. Obtaining a patent represents a real investment. Applicants must pay fees and go through an examination process with the help of a patent attorney. But patents are also a driver of innovation. Every patent application is published and adds new technical knowledge to the global pool of information. This information can be searched and used by researchers, engineers, and companies as a source of inspiration for further innovation. Finally, patents can facilitate collaboration and financing. They help structure partnerships, attract investment, and support new business initiatives. So now that we better understand what a patent is, let's see on the next slide what can be patented in plant breeding. The key principle is that plant varieties cannot be patented. The same applies to essentially biological breeding process. That means classical methods such as crossing plants and selecting the best offspring. Plants obtained from such processes are not patentable either. The same applies to naturally occurring genes. That's a discovery, and a discovery is not an invention and cannot be patented. Technical breeding process can be patented. These include techniques that directly modify genetic material, for example, genome editing methods, such as CRISPR, for example. Traits obtained through such technical processes may also be patented. For instance, a genetic trait that gives plants improved resistance to heat may be protected by a patent. What matters is that the invention is not limited to a single plant variety and that all the general conditions for patentability are fulfilled. Of course, in this presentation, I can only explain the general principle. In practice, each patent application must always be assessed on a case-by-case basis, and there is no simple yes or no answer. That said, the patent system also contains important safeguards for breeders, farmers, and researchers. We will see that on the next slide. For breeders, there is the breeders exemption. That means breeders can use plants with patented traits to develop new varieties freely. They don't need permission and they don't have to pay royalties. However, if the patented trait is still present in the new variety when it's commercialized, the breeder needs a license from the patent holder. The law also allows breeders to request such a license from the patent holder and, if necessary, enforce this right in court. For farmers, there is the farmer's privilege. Farmers who have lawfully purchased seeds may reuse year after year on their own farm the propagating material they harvest, even if it contains a patented trait. So they cannot be forced to buy new seeds because of patent right. Second, for farmers, it's the outcrossing exemption. If a field is naturally pollinated by wind or by animals with a plant carrying a patented trait, the farmer does not infringe the patent. He can freely sell the harvest. Finally, researchers benefit from a research exemption. They may study the invention, test it, or explore new applications freely. And if researchers need access to a patented biotechnology research tool, such as CRISPR, the law also provides the possibility of a compulsory license if reasonable access cannot be obtained on the market. So, you may now wonder whether NGT could make the current framework outdated. Let's take a look at that on the next slide. One point is often overlooked. The impact of patents mainly depends on how NGT are regulated. If NGT plants are regulated in a restrictive way, for example, similar to GMOs, their use in plant breeding will remain limited and patents will have little practical impact. If, on the other hand, NGT plants are regulated more like conventional varieties, the use will likely increase and we may see more patented traits used in plant breeding. The IPI has carried out a number of analyses and commissioned several studies. They show that Switzerland and its patent system provide an innovative and competitive environment for breeders and for breeding. Patent landscapes show that NGT patents are filed by both large companies and SMEs, and by public as well as private actors. Studies show that licensing is happening, including for CRISPR-Cas9 and other newer genome editing technologies. These elements explain why no modification of Swiss patent law is currently considered necessary with regard to NGT patents. So we see no short-term impact on breeding. And in the long term, however, if patented traits become widespread, access to genetic resource could become more complex. This is therefore something that needs to be monitored over time. And for farmers and consumers, our studies show no direct impact. The studies supporting this conclusion are available on our website. I will share the link in the chat after my presentation. Now let me briefly address transparency with the next slide. In practice, identifying relevant patent is not always easy. In the research and development process, patents usually appear several years before plant varieties. As a result, a patent does not indicate which variety will eventually contain the trait. At the same time, plant variety registers or official catalogs do not show whether a variety contains a patented trait. Improving transparency on this point would also improve legal certainty for breeders. On this basis, the IPI developed a draft proposal to create a transparency platform that would help breeders identify potentially relevant patents. The public consultation has already taken place, and while participants support the objective of improving transparency, stakeholders also emphasize that any Swiss solution should remain compatible with development in the European Union. This is especially relevant because discussions have also progressed at the EU level. The EU trilogue has recently reached a provisional agreement on the regulation of NGTs. Importantly, this agreement does not foresee a patent ban, but focus on transparency, licensing, and monitoring. The European text foresees the creation of a register for NGT1 plants, indicating related patents. It also proposed a code of conduct, encouraging stakeholders to improve transparency and to facilitate licensing. This approach builds on existing initiatives such as PINTO, ILP, and ACLP. In this context, the IPI is currently working with Swiss stakeholders to explore possible solutions. The Swiss situation presents specific challenges because transparency would need to cover all patents relevant for breeders, not only NGT patents. The objective is to develop a solution that works in practice for both breeders and patent holders, and that remains compatible with the emerging European solution. The proposal responding to the parliamentary motion is planned for submission to the Swiss Federal Council by the end of 2026. And I will conclude with a few key messages on the next slide. Patent and plant variety protection are often presented as conflicting systems. In reality, they protect different aspects of innovation, and together they form a system that supports plant breeding innovation. Second, plant as such and essentially biological breeding processes remain excluded from patent protection. The Swiss patent system already includes several safeguards for researchers, breeders, and farmers. Third, the impact of NGT patent on breeding will mainly depend on how NGT plants are regulated. And finally, transparency in plant breeding patents has become a key topic in current policy discussions. The challenge now is to turn this principle of transparency into practical solutions that support innovation. Thank you.